All right, we're going to talk about real numbers and their properties today, and then we'll talk briefly about clock addition. So when we're talking about real numbers, we got to talk about all these subsets of numbers. So the first one is the natural numbers. So the natural numbers are those numbers that you first learned how to count with. 1, 2, 3, 4, 5, 6, 7, so on and so forth. Now the natural numbers is a subset of the whole numbers. Now the whole numbers adds in 0. So now it becomes the whole numbers is 0, 1, 2, 3, 4, 5, 6, 7, so on and so forth. The integers are the whole numbers and their negations. So it's dot, 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 -4, -3, -2, -1, 0, 1, 2, 3, 4, dot, dot, dot. The rational numbers encompasses all the integers, the wholes, and the natural numbers. But it's all numbers that have a terminating or repeating decimal. So it's numbers that can be written as a fraction, a over b. So that might be things like 1/3, 5, 5.3 repeating. Those are all rational numbers. Now we have irrational numbers. Irrational numbers are numbers that have a decimal that does not terminate and does not repeat. So those are things like pi, square root of 2, square root of 3, and all these numbers are the reals. Now the nice thing about the reals is that it does have order. So there is this order, larger, comparison, smaller. And so what we're going to look at placing these numbers in their system, okay? So I'm going to start with the natural numbers. Well, the natural numbers are numbers that don't have a decimal and are positive, okay? So I come here and I notice that I know the square root of 9, it's 3, so the square root of 9 is a natural number. So a whole number now is all the natural numbers plus 0. So if I look here, here's 0, and I have the square root of 9, because the square root of 9 is 3. Now, integers are negative natural numbers, so the negation of the natural numbers, and 0. So I look at all the numbers that don't have a decimal. So -9, 0, square root of 9. Those are all my integers. Now, my rational numbers are all the things over here, plus any that have a terminating or repeating decimal. So I have -9, -1.3, 0, 0.3 repeating, and square root of 9, because square root of 9 is 3. Now my irrational numbers are those numbers that do not have a repeating or terminating decimal. So I notice here that I have pi halves and the square root of 10. Now all of these, all the numbers that are in my rational and the numbers that are in my irrational are my reals. So this would be -9, -1.3, 0, 0.3 repeating, square root of 2, square root of 9, and then the square root of 10. Okay? So that's just kind of classifying numbers there, kind of putting them in the right one. Remember, if it's a natural number, it's a whole number, it's an integer, it's rational, and it's real. If it's a whole number, it's an integer, it's rational, it's real, so on and so forth. Now we're going to talk about properties. And in our properties here, we have the addition side and the multiplication. So we have this idea before we get into properties of closure. Closure just means that if I start with a real number, so if I have a real number plus a real number, I will have a real number, okay? So that's that idea of closure, that it'll be in that same real system. So I have commutative property. So the commutative property, I have addition and multiplication, tells me order does not matter, okay? So A plus B is the same as B plus A times B is the same as B times A. I have the associative property. So the associative property says that in addition and multiplication, it doesn't matter which ones I use inside the parentheses, it's going to give me the same thing. So parentheses A plus B parentheses plus C is equal to A plus parentheses B plus C parentheses. And then multiplication says parentheses AB parentheses times C equals A parentheses B times C parentheses. Our identity just means that I'm getting back to my initial object, okay? So the identity property of addition is, what am I going to add to A to make it equal to A? A plus 0 is A, okay? Multiplication. What am I going to multiply A by to make it A? A times 1 equals A. Now, inverse is getting back to that identity value. So what am I going to add to A to make it equal to 0? Well, I'm going to add negative A. So the inverse addition property is A plus negative A equals 0. The inverse multiplication is A times 1 over A equals 1. And then we have our distributive property. A lot of you guys are really familiar with this. This is A times the quantity B plus C equals AB plus AC. Now, here's our properties, or our expressions, and we want to name that property. So in the first one, I have square root of 3 times 7 equals 7 times the square root of 3. So what I did is I switched my order. Which one of these tells me order doesn't matter, and that's commutative. So I would say the commutative property of multiplication. Okay? And here I have parentheses 4 plus 7 plus 6 equals 4 plus parentheses 7 plus 6 parentheses. So I've taken what's inside my parentheses and changed it, and it's addition. So here I have the associative property of addition. Okay? So the last thing we're going to talk about is this idea of clock addition. So if I had a clock, and in your book they use a clock with 5 here, but even if I had 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12, 1, 2, 3, 8, 9, 10, 11, 12. Now, I can go 2 plus 3 here, right? Like, if I were talking about these being hours, the 2 o'clock plus 3 hours, that's going to give me 5 o'clock. But what happens if I'm at 10 o'clock and I want to add 5 hours? Well, the addition, like straight addition, says that this is 15, but we don't have a 15 in here. So all they're saying is you got to have this symmetry, this kind of idea that you're going to kind of wrap around. So if I came here on my clock, I would go 1, 2, 3, 4, 5. This would be 3 o'clock. So it's going to revert back to that. So that's clock addition. I didn't want to spend a lot of time on that. I really wanted to focus on real numbers and their properties.